So we continue with the carbonyl compounds, and now we are going to study about the amorphous electrons of carbon. See, in the previous two videos we saw that what are the crystalline form of the carbon, that is the diamond and graphite, and now we are going to see what are the amorphous forms of the carbon or the electrons of carbon. So amorphous, as we said earlier, that it was something which does not have a proper geometrical shape. So if any particular compound doesn't have a proper geometrical shape, we call it as an amorphous kind of a substance. So in this, the main things are, there are four different kinds of amorphous kind of carbon, and they are, the first one being coal. Now, coal is something which is naturally occurring in the Earth's crust, and of course, it is going to be developed due to the fossil. It's a fossil fuel. Basically, the land is going to get above it, and so as the land layer keeps on increasing, there is pressure developed on the lower part of the land, and that particular lower part of that particular soil becomes hard and becomes slowly and steadily it becomes converted into coal. And depending on what is the percentage of carbon present in the coal can be differentiated into, first is the peat coal, which is having only 16% carbon in it. Then it is lignite coal, which is having 65% carbon in it. Then it is bituminous coal, which is 85% carbon. And finally is anthracite, which has got 90% carbon in it. So depending upon what is the percentage of carbon present in that coal, the efficiency of the coal or the heat capacity of that coal is going to keep on increasing. So heating capacity of the coal is going to keep on increasing. So we see that occurrence wise formed in nature as a result slow bacterial decomposition of vegetable metals that under the influence of heat, pressure and limited air over millions of years, and the different stages of formation of the transformation of the vegetable matter results in residue rich in varying amount of carbon, hence giving rise to different kind of coal. So that is peat coal 60% carbon, lignite coal 65% carbon, bituminous coal 80% 85% carbon, and anthracite containing 90% carbon. What is important in this case is the properties of the coal. So we know that the two kind of coal, that is the bituminous coal and anthracite, are the two ones which are normally used in a large scale in industries because they have got a very good amount of heat giving capacity. So a bituminous coal is a hard variety of coal which burns with a smoky flame, and whereas anthracite is a superior quality of coal which burns with a non-smoky flame. So that's anthracite becomes much more important for industries because it does not give you a smoky flame, and hence when it is used, it gives you almost like a pollution-free kind of a use of the carbon. So that's the two kind of coal which we are using, that is bituminous coal and anthracite. Hence the uses of the same is, coal is used mainly as a cheap fuel, like petroleum coal is also a fossil fuel. So like petroleum, coal is also a fossil fuel. It's a fossil fuel. It is mainly dependent on the fossils, that is the the settling down of the dead and decayed plants and animals inside the soil for years together, millions of years together. And it is also used for manufacturing of coke, coal gas and synthetic petrol. So yes, coal itself is used for making something like coke or coal glass and synthetic petrol. So that was about the coal, very simple. The second one is coke. Okay, coke, not Coca-Cola, right? Okay, coke is again, it is obtained by heating bituminous coal to high temperature of around 1300 degrees Celsius in absence of air. The volatile impurities escape and the residue is coke. The process is called as destructive distillation of coal. Now we saw in the earlier part that bituminous coal, we had that bituminous coal had got 85% of carbon. Now this 85% of carbon which is there, because of the 85% carbon and 15% having the impurities in it, it gives rise to a smoke while it is getting burned. So it is going to give you a smoky flame which is going to be harmful for the environment. So what we do is that we take this bituminous coal and heat it at 1300 degrees Celsius in absence of air. So when it is in absence of air, it doesn't completely burn out, but it is what is happening is the impurities present are going to get burned off, and what is remaining is pure carbon. This pure carbon is nothing but coke. Okay, so the residue of this particular heating of the bituminous coal at 1300 degrees Celsius in absence of air gives rise to coke. So when this process is called as destructive distillation of coal. Okay, so destructive distillation of coal is going to give rise to this particular kind of the coke. Property wise, coke is black, porous material which burns with almost no smoke. So that's the advantage, you know. See, anthracite jo hai, which has got 90% of carbon, is very difficult to obtain because it is going to be at a very deep down into the earth's crust. Okay, because it's very deep down the earth's crust, so removal of that thing is dangerous. At the same time, the quantity available may not be so high. The temperature at that depth is very high, so it is much more not viable to obtain that particular thing. So what we are doing that we are using bituminous coal, which is easily available, and converting it into better product than anthracite, so that we get a coal which is nothing but coke, which gives you a non-smoky flame. So coke is black, porous material which burns in almost no smoke and is a non-conductor of heat. It is a good reducing agent. Now, this is reducing agent means, okay, you learn in chemistry later on also in 9th standard and all that there is something which is like you need to, if you're adding oxygen to something, it's called as oxidation, and if you are removing oxygen from something, it is called as reduction. So coke is the one which is going to help you remove the oxygen from that particular metal, and hence it is called as a reducing agent. Okay, reducing agent ka simple meaning hai to remove oxygen from a particular kind of a oxide of a compound. Okay, this is mainly used in metallurgy where metals are not obtained in a pure form, but it is always formed in a combined form. So combined form में से जब इसको pure form में निकालना होता है, at that time we do a process which is called as reduction. So that reduction is done with the help of coke, because this coke has the affinity towards oxygen, and it removes oxygen from that particular oxides of a compound and makes the compound free from oxygen. So of course, so uses में क्या होगा? Coke will be a very good fuel because it burns without smoke. As a reducing agent in iron and steel production and in manufacturing of water gas and producer gas. So water gas and producer gas are going to be the one which is going to help you to generate hydrogen. So of course the hydrogen chapter is cancelled for your syllabus, but hydrogen chapter mein there is one process by which we can produce hydrogen in a large scale, and that is by production of water gas, wherein coke is going to be heated with steam. So coke and steam will give rise to hydrogen, water gas, and then it will give rise to hydrogen. So that was coke. The third thing is lamp black. So the third one which is going to be in this particular category of amorphous kind of electron is lamp black. Actually the word itself tells you what is lamp black. Now if you see a candle burning, okay, when a candle burns and if you keep some plate or something on top of it, और इवन दिया वगैरह भी जब भी जलता है तो हम लोग का प्लेट वगैरह रखते हैं, तो यू कैन फाइंड दैट अ ब्लैक कलर्ड पाउडर इज सेटल्ड ऑन दैट पर्टिकुलर प्लेट. ओके, सो दैट पर्टिकुलर प्लेट पे जो ब्लैक कलर जो आता है दैट इज नथिंग बट लैम्प ब्लैक. ओके, सो दैट्स अ वेरी सिंपल थिंग. इट इज ऑब्टेन्ड बाय बर्निंग सब्सटेंस रिच इन कार्बन, फॉर एग्जांपल kerosene oil, in a limited supply of air. On incomplete combustion, a large amount of smoke is liberated which passes into chambers having cooler parts. The soot, lamp black, settles down and is collected by scrapping. So yeah, it is just going to get collected as a black colored powder which you scrap it out and remove. Anyway, properties wise, the most important thing is the properties. It is soft black powder which almost is pure form of carbon. It burns with a little smoke and is a non-conductor of heat and electricity. So you can see that this particular thing is going to be helpful. So even after a kerosene has been utilized for some production, some kind of a thing, that particular lamp black which is going to be given out, that lamp black can also be you acting as a fuel. So that's the advantage of the thing. So which is a pure form, it burns with a little smoke and non-conductive heat and electricity. Uses lamp black uses for making printer inks, black shoe polish, typewriter ribbons, and black paints. It is also used as a filler in rubber tires. So you can see it is of course not used much as a fuel, but the powder is used to color anything black in industries. The tires, what we see, that they are black in color. So that black color kahan se mila? So we are adding lamp black to the rubber so that the whole tire become black in color. Similarly, the printer inks, okay, the printing inks are black in, जो भी black color में है, या तो refill का जो ink है वो black color में है, या तो laser printer का जो powder है वो black color में है. Shoe polishes which are black in color, typewriter ribbons and black paints, all these can require lamp black for making it black. So that's why the lamp black is going to be utilized in an industry other than fuel, okay, other than fuel, because no doubt it burns with a very little smoke and it is a non-conductor of heat and electricity, but still we do, because it is already it doesn't burn too much, it doesn't have that particular calorific value to burn anything, so that's why it is used mainly for colored purpose rather than any fuel purpose. The fourth one over here is going to be the charcoal. Now charcoal, as we saw earlier, is of different kinds. So first of all, we are seeing that the charcoal is, what we are going to see is the wood charcoal. See, we have learned that the charcoal was of wood charcoal, sugar charcoal, bone charcoal, right? But what we are going to see over here will be mainly the wood charcoal. It is a wood charcoal we are going to study much more in this particular chapter. So preparation wise, wood charcoal is obtained as the residue on destructive distillation of wood. We had learned destructive distillation of coal. Destructive distillation of coal gives you coke, okay? Coal, when burned in absence of air at a high temperature, becomes pure carbon, which is nothing but coke. Similarly, if I take wood and if I burn the wood in absence of air at high temperature, it is called as destructive distillation of wood, which gives rise to wood charcoal. Okay, so wood charcoal is obtained on residue on destructive distillation of wood, heating wood or out of contact with air and distilling the product. The product of destructive distillation of wood are liquid products are pyroligneous acid and wood tar. Gaseous product is wood gas, and the residual product is wood charcoal. So when you are burning the wood, you are not only getting the wood charcoal, but you are getting three products. The liquid part is called as pyroligneous acid and wood tar, and the gaseous product is the wood gas, and finally is the residual product, which is nothing but the wood charcoal. Properties of the wood charcoal is that it is greyish black, soft, porous, solid, and a bad conductor of heat and electricity. Wood charcoal has a very large surface area and hence absorb large volumes of gases. Now this is a difference. It's not absorb, it is adsorb. There is no spelling mistake over there. It is adsorb. Adsorb means it has got the capacity to entrap the gas around itself. Okay, it is going to entrap or encapsulate a gas around itself. So that is called as absorption capacity. So wood charcoal is a greyish black, soft, porous solid, and bad conductor of heat and electricity. Now what is adsorption? Let's understand what is adsorption. It is a property due to which a substance accumulate gases or liquids on its outer surface. Adsorption is thus a surface phenomena. So if I'll give a small example. Many times you find that some kind of a waterproof material is such that when you suppose say the gloves with the gloves are waterproof. So what happens is that when you put your hand inside, तो अगर ऐसा होगा कि वो अंदर डालने से there is when you remove it there is not even droplets of water present on it. Okay, not even droplets of water. See, normally क्या होता है कि अगर डालेंगे तो गीला तो होगा ही, right? But only thing is your hand is not going to get wet. But suppose it is such that when I put it inside and put it outside, there is no even water droplets on it. Why would that happen? Because it is completely waterproof, means it is repelling the water. Okay, what is happening is that it is repelling the. How does it repel the water? If there is some kind of a gaseous material around it which is not allowing the water to seep inside. Okay, वैसे टाइप का कुछ रहेगा तो that particular gaseous material around it is nothing but the process of adsorption. So that's what we say, that it is a property due to which a substance accumulates gases or liquids on its outer surface. Adsorption is thus a surface phenomenon. Adsorption capacity. To increase the adsorption capacity of wood charcoal, a process called activation is carried out to give activated wood charcoal. So you want to increase, you want more and more kind of such a thing to happen, that the adsorption should be higher. So adsorption should be higher means more amount of gases should be around it, so that it is helping the process. So for such a condition, we are doing a process which is called as activation. So that particular activated, the product is called as the activated wood charcoal. Activation is done by heating wood charcoal in retorts around 99 degrees Celsius and passing steam over it. The impurities of the surface gets removed and adsorption capacity increases 100 folds, it is 100 times. Okay, so what we are trying to do is that we are using this particular wood charcoal. ये wood charcoal को हम लोग heat करेंगे, and that heating process is in a retort. That means it's a flask where it is going to be heated at 99 degrees Celsius, and steam is made to pass through it. When such a thing happens, the outer covering which has got the impurities on it, that impurities get removed, and when they get removed, automatically the adsorption capacity, then because after that it becomes pure kind of a wood charcoal. So that pure kind of activated kind of a charcoal will have more adsorption capacity, which is almost 100 times what it was having earlier. Now another thing is that the wood charcoal has got a affinity towards oxygen. That means it is going to attract oxygen towards itself, or in other ways we can say that it is going to remove the oxygen from a compound which has got oxygen in it. So suppose I have got copper oxide, and copper oxide के साथ में अगर मैं wood charcoal को react करूँगा, तो what will happen? The copper oxide में से oxygen बाहर निकल जाएगा and copper will be available to me. This is exactly what I explained you for coke in case of reduction. So reducing agent. So even this particular thing, so we can see that the affinity of oxygen is there, which is giving it a reducing agent. It becomes a reducing agent. So wood charcoal reduces heated metallic oxides to the respective metals. So ZnO plus C will give you Zn plus CO. Fe2O3 plus 3C will give you 2Fe plus 3CO. So wood charcoal reduces superheated steam to oxygen along with formation of carbon monoxide, which is nothing but carbon plus water at 1000 degrees Celsius give you CO plus H2. This is nothing but water gas, which I also told you earlier during the process of coke. So water gas and producer gas is what we said. So producer gas is nothing but carbon plus water, that is steam, and the water gas is nothing but carbon monoxide plus hydrogen. So the mixture of carbon monoxide and hydrogen is called as water gas. Okay, so that is an important part over here. So you can see that the property wise, the properties of the wood charcoal are very important, because it has got two main important properties. That is, first is adsorption capacity. It has got some adsorption property over there, and the second one is its reducing agent property. As a reducing agent, it has got affinity towards oxygen, hence it is used as a reducing agent. Accordingly, what will be the uses? So wood charcoal is used in a household fuel, burns without smoke and easy to ignite. As an adsorbent, absorb gases, both foul and poisonous gases, hence finding applications in gas mask, sewers, and during indigestion. And it also absorbs organic coloring matter, and it is used as a decolorizing agent. So you can see that it has got that absorbing capacity, so it can absorb the gases and all, because it is going to absorb that thing. That's why what will happen, there will be gases which are creating kind of a problem to you, that can easily be sorted out using wood charcoal. So that's why they are giving the example that it, of course, it is used as a fuel. So wood charcoal, of course, because it is a good carbon content is very high, so it can be used as a fuel, of course, because easy to ignite and non-smoky. But the adsorption जो property है उसके कारण it is able to remove the foul or poisonous gases from that particular area, and hence it can be used in the mass which are having the gas mass which has got certain kind of available, so that the filtration takes place of the air which is coming inside. And it also absorbs organic coloring matter and is used as decolorizing agent. Apart from the wood charcoal, we also have two more kind of charcoal, and that are the bone charcoal and the sugar charcoal. So bone and sugar charcoal are two more types. So it is an amorphous allotrope of carbon, bone charcoal, obtained by destructive distillation of animal bones. So when I do the destructive distillation of both, see, we did destructive distillation of wood and we got wood charcoal. So we do the destructive distillation of bone, we get bone charcoal. We do destructive distillation of sugar, we get sugar charcoal. So sugar charcoal is an amorphous allotrope of carbon obtained by destructive distillation of cane sugar. So this way, these are the amorphous allotropes of carbon. Okay, that is the coal, coke, lamp black, and charcoal, which are of three kinds: wood charcoal, bone charcoal, and sugar charcoal. There are certain experiments which are based over here on these allotropes. So we can say that first one is the making of the lamp black. So I explained you earlier also that if you take a lamp के दिया ले लो, दिया जो रहता है, दिया के ऊपर जो है दिया जल रहा है और उसके ऊपर हम लोग अगर समझो एक पर्टिकुलर पेपर या ऐसा कुछ भी रख लेंगे, तो the smoke of the burning diya is going to be coming on this particular surface, and when you find after some time it will be completely black, it will be charred. And if you take a finger like this, you will find that a black colored powder comes in your hand. That black powder, what you are getting over there, is nothing but the lamp black. You must have also seen this when you have seen any kind of a lantern, the lantern which are using kerosene or something. You'll find that lanterns also have got a black color suit around this particular area. So that is also the same thing, which is nothing but the lamp black. Then we have to prove that the wood charcoal absorbs ink. So in this case, we are taking a blue colored ink solution, and to this blue colored ink solution, we are putting just some few pieces of wood charcoal. When you put a few pieces of wood charcoal, you find that the whole water the color will be from dark blue to fades. The blue color fades. Why does the blue color fade? Because the blue color has been absorbed by the wood charcoal. So the wood charcoal has, being a large surface area and a strong absorbance, so it hence absorbs organic coloring matter and decolors it. So the blue ink of the solution fades. And finally is to prove that wood charcoal is a reducing agent. So this is the property wherein you are going to use a oxide of a metal, and you are allowing the oxide of the metal to pass through a particular wood charcoal. So or you can just take wood charcoal and oxide of metal together and start heating it in a particular, you will find that it is going to give rise to a gas which is nothing but carbon monoxide, and the resultant the metal what is going to remain will become pure copper. So that's what they are saying, that you are taking a black colored copper oxide. See, copper oxide, when it is copper is, that it is the color of copper is reddish brown, but when it becomes an oxide, it becomes black in color. Now this is very easily seen even in your house. You can see that everybody, I think, has got the piped gas in your house. So the piped gas in your house has got the copper tubing. So the copper tubing, वो एक मीटर रहता है, मीटर से एक ट्यूब जा रहा है, वो copper tubing है. जब भी वो नया था, it was having that particular color which was reddish brown. But now if you see, it would have turned into blackish color. That means that the oxygen from the air has reacted with the copper and formed copper oxide layer on top of it. Okay, so that's why we see that copper oxide is black in color. So this black in color copper oxide in a powdered charcoal are put in a cup in a hard glass test tube, and then it is being heated. So when you heat this thing, the copper oxide reduces to reddish brown copper, and the carbon monoxide is going to be bubbled out, and it is going to pass through palladium chloride solution, which turns white to pink, proving that the gas was carbon monoxide. So this is a test for carbon monoxide. So if I want to find out whether a particular gas is carbon monoxide or not, I'll pass this gas through palladium chloride. Okay, palladium chloride is white in color, but as it comes in contact with carbon monoxide, it turns pink. So if it turns pink, it proves that the gas which was evolved was nothing but carbon monoxide. So this is how the wood charcoal is used as a reducing agent. So this is about the amorphous kind of carbon, or you can say amorphous allotropes or carbon. So I think I'll end the video over here, because in the next part I'll take it in the next videos. Okay, thank you.